Hello everyone, myself Shivaji Sonawane, working as a research scholar under the supervision of Professor N.B. Saure at Department of Physics, Savitribai Phule Pune University. Now I am going to present my research work in the international conference, Material for the Energy and the Devices, organized by the Banaras Hindu University. The topic of my research is the characterization of ZnTe material prepared by electrodeposition method as a back contact for a CdTe solar cell. The motivation behind this work is the energy demand increases with increasing population, and this energy consumption expected to be increased up to the 34% by the year 2035. There are two types of the energy sources, that is the renewable energy sources and non-renewable energy sources. In case of non-renewable energy sources get diminished in next 120 years, and there is a problem of pollution. In case of renewable energy sources, it is economically compatible and the green source of energy. Then out of this renewable energy source, the sun is the infinite source of energy on the earth's surface. It produces 84 terawatt of energy in 24 hours, and one need only 12 terawatt of energy in 24 hours. The solar energy contribution in the world energy production is less than 0.1%, and it is minimum. It is due to the higher price of photovoltaic, this model. So these are the different types of the solar cell. First generation solar cell consists of this monocrystalline and multicrystalline silicon material. And the second generation solar cell consists of this amorphous silicon, CdTe and CIGS solar cell. Out of this, I am interested in the CdTe solar cell, and its highest efficiency reported till now it is 22.1%. In the third generation, it consists of multi-junction solar cell. Its reported efficiency is 38.8%, and the fourth generation consists of the hybrid solar cell. Then this is the photovoltaic market contribution. Silicon, this crystalline silicon solar cell consists of 85 to 90%, and this thin film solar cell consists of 10 to 15%. And it is minimum due to the high production cost and the limited efficiency. Its contribution is less in the world energy production. So there is a scope to develop the thin film technology. Till date, its contribution is about 6 to 10% in the total production. So there are some advantages of this thin film solar cell. It is used for the large deposition of the layer. Then heterojunction formation gives the possibility to reduce the optical absorption losses, and which improve the device performance. Then efficiency can be improved by using the multi-junction solar cell. Then there is a choice to choose the substrate, like as a metal, flexible substrate, then polymer foils for the lightweight model, as well as possibility for the roll-to-roll manufacturing to enhance the deposition speed also. These are the two structures, solar cell structure. One is known as superstrate, second one is known as substrate configuration. In case of superstrate configuration, the light is get incident from the substrate side, and in case of substrate configuration, the light is get incident on the opposite side of the substrate. So these are the some advantages of CdTe solar cell. It is the group second and fourth semiconductor, and it is from the family of chalcogenide with zinc plate structure. And the most successful combination of the solar cell is the CdS-CdTe. CdTe solar cell is the second most common photovoltaic technology in the world, with 5% of share in the world market. It has the band gap about 1.45 electron volt and highest absorption coefficient 10⁵ centimeter inverse, which is 10 times greater than the silicon. It is direct band gap semiconductor, high stability and high term performance. Within a 1 to 2 micrometer of thickness, it absorbs more than 90% of incident light. This is the second generation solar cell with the record efficiency 22.1%. So this is the design of CdS-CdTe solar cell. Then this is the energy band diagram of this structure. Then this electrochemical technique is used for the synthesis of this absorbing material as well as this interface layer also. So these are the advantages of this electrochemical technique. Capital investment is negligible, no maintenance. Then maximum material is get utilized, greater than 90% deposition rate is fast. It does not require high purity chemicals, and the toxic gases are not involved in this process. So this is the conventional three electrode deposition system in which FTO is used as a working electrode, graphite as a counter, then AgCl as a reference electrode. The precursors which are used for the deposition of ZnT material is the tellurium oxide, zinc sulfate, and citric acid as a supporting electrolyte. Then the solvent is the double distilled water, and is electrode deposited at the room temperature. So this ZnT thin film is get electrode deposited at the room temperature, and the deposition potential is minus 0.9 volt. So this is the X-ray diffraction spectra for as prepared film as well as annealed thin film. This as prepared ZnT film exhibits the amorphous nature, but after the heat treatment at 400 degrees Celsius, it shows the four prominent peak, and which gives the mixed phase crystal structure of ZnT material. And these four prominent peaks at the this all this FWHM as well as this interpennial distance as well as phase assays and the crystalline size according to the Debye's formula is get calculated, and it is nearly 70 nanometer. So the absorption study is carried out by using the UV visible spectroscopy. Then in this two graph shows the tau plots for as prepared and annealed ZnT thin film. Then according to these two plots, this band gap of this material is get decreased by up to 7%. It is due to the increasing grain size and the recrystallization of the material. This is the Raman spectra. It record at this excitation wavelength 532 nanometer, and the power is 15 milliwatt. It shows the peak, that is A1 mode of tellurium peak, and the two longitudinal phonon modes of ZnT material. Then the ACM images of this as prepared and annealed ZnT thin film, which shows the globular morphology in which the particle size is uniform and it is getting increased after the annealing. It is due to the recrystallization. Then EDAX is used to find out the elemental composition, and according to this EDAX, it shows the stoichiometric composition, nearly stoichiometric composition of zinc and tellurium. Then this is the survey scan spectra, which is obtained by using the X-ray photoelectron spectroscopy. And according to the survey scan spectra, it exhibits the presence of carbon, oxygen, then tellurium, and the zinc peak, and it shows the presence of this material in the thin film. So this is the core level spectra for the zinc as well as tellurium, and in both the core level spectra, it shows the doublets, and this doublet indicate that in both the cases, according to this two doublet, this core level spectra shows the presence of the chemical state of zinc 2 plus and tellurium 2 minus. Then this is the measurement of electrical study for the FTO, ZnT, and gold structure. In this case, the current is get increased after annealing. Then this graph, that is the JV graph, is used to find out the ideality factor and the barrier height, which which is tabulated in the table. Here the ideality factor is get decreased after annealing and the barrier height is get increases. Then this is the mode Schottky plots, which is used to find out the flat band potential and the carrier concentration. This carrier concentration is get increases after the annealing, and it is due to the photo generation of carriers is get blocked after annealing. So its carrier concentration is get increases. Then this is the solar cell structure is get manufactured, which consists of FTO as a substrate, CDS as a window layer, CdTe as absorbing material, and ZnTe as an interface layer, and there is a gold metal contact. So this is the actual photograph of this solar cell structure. This is the deposition of CdTe material, and this is the images of ZnTe material. Then this JV characterization of this solar cell structure under dark and illumination condition is get carried out to find out the major 4 parameters of the solar cell, that is the VOC, JSC, fill factor, and the efficiency. According to this graph, this VOC, JSC, fill factor, and the efficiency is tabulated in this table, and at the initial stage, the efficiency of the solar cell is 3.36%. Then this diode equation is used to calculate this shunt conductance as well as series resistance and the ideality factor for the solar cell structure. So this graph consists of dj by dV versus applied potential, which is used to calculate the shunt conductance, series resistance, and the ideality factor. So this is the value which is calculated according to the structure, and this is the solar cell procedure. CDS is deposited by the chemical bath deposition annulled at 450 degrees Celsius for the 15 minutes. Then electrodeposition of CdTe. Then after this, there is a CdCl2 treatment. Then anneal at 400 degrees Celsius for 15 minutes, and before the deposition of this interface layer, it is get etched in bromine methanol. Then the deposition of CdTe material, this ZnTe material, which is annealed at 400 degrees Celsius, and finally there is a metal contact by the thermal evaporation method. The conclusion, in the conclusion, CDS layer is get deposit on a pure substrate by low cost method, CBD method. Then by using the low cost electrochemical method is used to deposit the CdTe as well as ZnTe material. Then the superstrate solar cell structure is get fabricated, which shows the power conversion efficiency 3.36%. And after optimization of this annealing condition, CdCl2 treatment, and bromine methanol etching, the efficiency of the solar cell is get increased. Thank you.